Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is matrices. What you are going to learn today is how to find the determinant of a 2 by 2 matrices. So let's begin. After completing the very lesson today, my dear student will be able to find the determinant of a 2 by 2 matrices. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, in your favorite segment of the lesson, Mercies Fun, today I'm happy to give you another special group of numbers. And this group of numbers are called the Caprekar constant or Caprekar numbers. I will explain what a Caprekar constant after my lesson today, so don't go away. To begin the lesson, my dear student, let me first explain what is determinant of a matrix. So determinant of a matrix is a real number that is associated to each and every square matrix, which means it is only square matrix that has what we call a determinant, or rather, it is only square matrix that you can find it is the determinant. And that determinant is just a real number associated to that very square matrix. If, for example, you have a matrix M, its determinant is usually denoted by this very symbol that M, or M, that is the name of the matrix within the two structures, as you can see here. This is another symbol for determinant of a matrix. Similarly, for other letters, that is for other matrix, the name of the matrix, if it is matrix A, then its determinant will now be that A, or the letter A, capital letter A, written within the two structures, just like this one. So these are the two symbols for determinant of a particular matrix. So next is to learn how to find the determinant of a 2 by 2 matrix. So suppose you have a matrix M, which is the 2 by 2 matrix, and the entries there, it is A and B in the first row, C, D in the second row. Assume these are the elements inside this matrix M. So determinant of this very matrix denoted by this symbol, as you can see here, that M, or M written within these two structures. So determinant of this very matrix. Let's learn what the rule tells us to do. So what the rule says, you now multiply A by D. That is the elements diagonally down. That is A times the D. You now multiply them together. Write the result. And that result, that product, you now said minus then the other entries, that is diagonal up, C and D. You multiply them together. You now subtract those product also. So determinant of matrix M, that is which is a 2 by 2 square matrix, what we simply do, the two entries diagonal down, their product, minus diagonal up. These the two entries. So you have A times the D minus C times B. This is what we simply do to find the determinant of this 2 by 2 square matrix. We are going to make use of this very rule and find the determinant of 2 by 2 square matrix. So let's move and take examples. Example number 1, it says given matrix A with entries 5, 6 in the first row, 7 and 3 in the second row. So this is a square matrix. The question asked is to find or to evaluate det A. Det A simply means a determinant of the matrix A. Solution to this very problem, we now copy the given matrix, that is matrix A. Determinant of it, that is A, written within these two structures. You can see it's no longer square bracket. So this means determinant of the matrix A. So what we do, according to the rule, it says we now multiply 5 by 3. That result minus the product of 7 and 6. So let me do that. So this is now going to be the determinant. 5 times 3. 5 multiplied by 3, the result minus this result also 7 by 6. So you perform these two multiplication, the two results you now subtract. So 5 times 3 gives you 15 and 7 times 6 gives answer 42. So subtracting 42 from 15 will now give you determinant of this very matrix A. And that answer is now going to be minus 27. So minus 27 is the determinant of this very matrix E. Let's just move and take another example. Example number 2, we ask to find the determinant of this very matrix B with this entries to 2, 4 in the first row, minus 3 and minus 5 in the second row. Solution to this very problem. Copying the given text, that is determinant of the matrix B. So the rule tells us the product diagonal down minus the product diagonal up. So let me do that. This will now be equals to 2 multiplied by minus 5, that is the product diagonal down, minus the product diagonal up, that is minus 3 times 4. So I'm going to subtract this product. So I'm going to have minus 3 times 4. So I'll now do the multiplications. So 2 times minus 5 gives me minus 10. And minus 3 times 4 gives me minus 12. And I have another negative outside. So that makes it positive 12. So minus 10 plus the 12, that gives result to positive 2. So this will now be determinant of this very matrix B. Let me just take one more example. Example number 3 says, given that the matrix E has this entries y and minus 2 in the first row, 3 and 1 in the second row. So this is another 2 by 2 square matrix. And suppose determinant of this very matrix E is given as minus 4. The question asked is to find the value of y. Y is one of the entries in the matrix E. Look at the entry y. Solution to this very problem. Here we have the matrix, and we have the determinant of that very matrix. But in the given matrix, one of the elements of that matrix is not known. It is letter y. It is that entry that we are going to find. So let me just copy the given matrix. That is the determinant of that very matrix is now given as minus 4. So you have this matrix y minus 2 as the elements in the first row. 3 and 1 in the second one. Determinants of those of that matrix of those elements is given in the question as minus 4. Look at it. So remember, to find determinant, we now said products of the entries diagonal down minus the product of the entries diagonal up. So I'm going to have something like this, that is y times 1, which is this minus 3 times minus 2. Let me just write it. And this result will now be equals to this very determinant, which we have here as minus 4. So I'm simplifying this very one. Y times 1 will give answer just to 1y. And minus 3 times minus 2 gives a positive 6. So to solve this very equation, that is to find the y, we will now take this positive 6 to the right hand side. There you have y equals to minus 4 minus 6. And the minus 4 minus 6 will give a result minus 10. This is now the value of this very y. So with these few examples, I have come to the end of this very lesson, my dear student. I hope you'll be able to find the determinant of any 2 by 2 matrices. Thank you for your attention, and let me just move to the last segment, Marcy's Fun, and explain what a Caprekar constant. So a number key is Caprekar number. If square of that number key, that result can be split into 2 numbers, and the sum of those two numbers give you back your number key. So let's just find out examples. Examples of Caprekar numbers. I have 9, I have 45. So let me just get 9 square. 9 square will be 81. If I now split this result 8, 1, that is 1 as one number, 8 as another number, I'm going to have 8 plus 1. This will give me result 9. And 9 is my original number back. So 9 is now a Caprekar number or a Caprekar constant. Let me take the next example, 45. I will now find it is square. 45 square will give you this result 2025 if you do it correctly. And this result, that is 45 square, can be split into 2 numbers. The 2 numbers will now be 20 and 25, and addition of those 2 numbers give you back your number 45. Look at it, 20 plus 25 will give you back the number 45, so which means 45 is a Caprekar constant. Other examples of Caprekar constant is 55, 99, 297, 703, and so on. All these are Caprekar constants. So I will now allow you to find their squares and split those squares into two numbers such that if you add those two numbers, you get your original number back. Thank you for your attention. We see more of this interesting thing in mathematics in our subsequent lessons.